Okay, so the next part of applying differential calculus is actually doing it in the context that's required, okay? In an exam, in any kind of test, there's lots of different contexts that it could be applied in, but it's basically just the work that we've been doing. It's taking a function, taking a formula, and finding the maximum and minimum values within that formula, okay? So it is just a differentiation question, and it is basically what we've been doing before, because chances are we'd have an interval, and we want to work out what's happening exactly within that interval, okay? So we can use this in lots of different contexts, okay? More often than not, you'll see it in terms of volume, but it can be used in profit, materials, accelerations, and also the volume, okay? But the point is, if there's a function to define the situation, whatever it is, whether it be one of those ones or a different function entirely, we can differentiate that function and evaluate it to find the greatest and least values, okay? And that's basically what optimization is. We're trying to optimize something. We're trying to find the kind of the extremities, almost, that what's the highest, what's the lowest. It depends on the question. It could be either one of them. The idea of the differentiation that we've done, and certainly in terms of finding stationary points, is that we can find both of those things. We can find the highest, we can find the lowest, but we've just got to remember that if there is an interval, the maximum and minimum turning points might not be the greatest and the least values within that interval. So there's just basically a couple of things to consider here. But as I say, it's virtually the same questions that we were doing in the last part. It's just now more of a context. And it's just, I guess the difficulty is actually recognizing what you're trying to do here from the question, okay? Right, one of the things to be aware of, this is an example, I'm just going to go straight in and do it, but this, generally optimization questions have two parts, okay? The first part is to find or to show that basically a formula, okay? So I'll find a formula from the information that's given to you, and then the second part is the whole optimization part, right? The first thing you need to be aware of is this first part is one of the most difficult bits that you can do in higher. It's one of the bits that people struggle with most. But the reason it's split up into two is if you can't show it, if you can't prove that formula, you can still do part B. And I can't stress that enough, okay? If for whatever reason you can't do A, and it can be a struggle, it can be awkward, but I'm going to show you in a couple of lessons. In the next video that I do, I'm going to basically go through a few different formulas and just focus on that, okay? But the point is, if you can't show that formula, you can still use that formula in part B and basically just do the work that we've been doing before, okay? But I'll go through part A and kind of show you the different aspects to look for, to keep an eye out for. But the point is, read the question, okay? Don't just look at the pretty picture, read the question, pick out the keywords and think about what's going on here, okay? So a small baking tin, right? We don't really care that it's a baking tin. We care about the shape. It's open top. First of all, that's important, okay? It's not a closed baking tin. If anyone has ever been in a kitchen before, you've probably established that a baking tin doesn't have a lid, okay? So this is open, in which case it's basically got the four sides around the outside and it's got the base. It is square based, okay? It's not highlighted, it's not bolded, but it's going to be important because it's a part of the shape, and we know, because obviously we've done extensive work, we know what a square is, okay? So we can use that to help us in the next part. If it's a square-based cuboid with volume 500 centimeters cubed, okay? So we know the volume, it's 500 centimeters cubed. We're clearly going to need that at some point, okay? And the fact that it's square-based and the fact that it's open-topped, okay? If you have this written down, if you want this printed out, or if you're using an exam, then highlight these words because you're going to need them all, right? The length of the base is X centimeters. Right? And you can see hopefully from this diagram that the height of it is h. It's not necessarily said in the question, but you can see hopefully clearly from the diagram that the height of the baking tin is h. Right. Show that the surface area. Okay, so the first bit here is the fact that it's surface area, right? We didn't say anything about surface area here. We don't know anything about the surface area, but that's why we're going to find a formula on it. But it's important. Surface area S of metal needed to make the tin is given by this formula. Okay, right. This is our answer, and that's the beauty of these show that questions. You know the answer in advance, so you take everything else that's there for you and you build up to this point. You try and get this formula from all the other information that's there, okay? And then part B is find the dimensions of the tin, which minimize the surface area. So the important part is this word minimize. As soon as you see minimize or maximize, greatest or least, whatever it is, then chances are it's an optimization question, okay? But we'll come to that in a second. Right, so we'll focus on this first bit, getting the formula. So we know this formula, but basically what we want to do is we want to take everything else and try and get. Okay, so we're trying to get a surface area formula. So let's start there. Okay, so we're starting with our S equals. Right, in terms of the surface area, as I said already, we've got four sides and we've got a base. Right, but what's special about those four sides is that they are all length X. And we know that because it's square based. So it says the length of the base is X centimeters, but the breadth of the base is also x centimeters because it is a square. If you have a square, all the sides are the same. Okay, so that x is there as well. Okay, so then we've got the sides are all going to be x by h. Okay, in which case the area of each side is x times by h, and we have 4 of them. Okay, so part of the surface area, at least at this stage, is we have 4 x by h's. So these rectangles at the side of our cuboid are all x by h. We have 4 of them, so the total area of the side is 4 times by x times by h. Because it's open topped, we don't need to worry about the lid because there is no lid. We just need to worry about the bottom. And the bottom is a square. Okay, and to find the area of a square, it is length times breadth. Okay, which in this case is x times by x. The simplest way of writing that is x squared. So we have a formula now. We have a formula for this for the surface area, but it's not like the one that they've given us. Okay, their surface area is x squared plus 2000 over x. So we need to look at this carefully and work out what the difference is between this one and the one that we have. Okay, right. The first thing I'd be observing, okay, is the fact that this formula here doesn't have an h. Okay, so if I can find another expression for h or another equation for h, okay, then I can get rid of the h. The other thing I'd be thinking about is the fact that they mentioned volume at the start of the question, and I've not done anything with volume yet. Okay, so that is my next target. I'm going to do something with the volume, and I'm going to use, hopefully it has h in it, and then I can join these two equations together. Basically what I'm going to do is going to substitute one into the other to get rid of the h, because that's what we're trying to do. We're trying to get a formula that doesn't have an h in it, and at the moment we do have a formula that's got h in it. And the only thing I can do other than what I've already done is work out something in terms of volume. Okay, right, yeah, that's basically what I just said. So volume of a cuboid is length times breadth times height, right? You don't get these formulas anymore, you have to know all of this. So if it's a cuboid, it's length times breadth times height. Right, we have all those things, we have expressions for all those things, we have letters for all of those things. Length is x, the breadth is x as well, and the height is h. And the point is we know the volume already. Volume is 500, so we can replace all of these things. Volume is 500, the length is x, the breadth is x, and the height in this case is just h. Right, so now we have a second formula. Okay, this one involves x's and h's. This one involves x's and h's, but the one we want to get doesn't have any h's in it. So what I want to do basically is I want to rearrange this formula, because at the end of the day, I want my formula, the formula in the question is to do with surface area. So I want this to remain, I want S equals, but I just don't want an H in it. So I'm going to rearrange this formula to give me H. Okay, so 500 equals X times X, which is X squared, times by H. So if I want to isolate the H, in other words, I want to change the subject to H, it's basically going to become H equals 500 over X squared. Right, now what I can do with this is I can take this part, okay, and replace the h in my original formula. Okay, so I'm going to substitute out that h, and I'm going to replace it with 500 over x squared. That will give me a formula for surface area that doesn't have any h's in, which this one doesn't. Okay, and then I can probably just play around with it a little bit and get it back to what I actually need. Okay, so I've got the 4x, I'm going to times it by the h that I've just found, so 4x times by 500 over x squared, and I've still got the plus x squared on the end. And I just want to simplify this down a little bit until it looks like this, okay, because I've got everything in place now. I don't have any h's in my formula, I've got a surface area formula, okay, so it's looking good so far. 4x times by 500 is 2000x, so multiply out the brackets, 2000x over x squared plus x squared, and just simplify this down. You've got a common factor of x there, so it's x squared plus 2000 over x. All I've done is swap them around. A plus b is the same as b plus a, but now it looks like what was required in the first part of the question, and that's part A done. Quite difficult, okay, granted it's quite difficult, but I've still just used all the information that's there in the question for me to get a formula. Right, so none of that's actually differentiation so far, but part B is where the differentiation comes in. But as you can see, it's a show that question. We're going to use this formula whether we found it ourselves or not, okay? So if you can't do part A in a question, in a test, exam, whatever it is, okay, then you can just skip on to part B and you can use the formula for part A regardless of whether you've actually obtained it yourself, okay? So find the dimensions of the tin which minimize the surface area, right? Don't worry too much about that, but the point is what we're going to try and find is we're going to try and find the minimum value in our interval, right? We don't actually have an interval in this case, okay? So we don't need to worry about that too much. But what we're going to do first of all is we're going to take this, we're going to differentiate it. So a couple of things to think about here. We're differentiating S with respect to X. But if I'm going to differentiate this, I want it in differentiable form. Okay, so I need to change this around and write it in differentiable form. 2000 over x is the same as 2000x to the power of -1. So now it's in differentiable form. Now I can differentiate and I want to write it properly. I'm finding ds by dx. Okay, x squared differentiated is 2x. Move the minus 1 to the front so it becomes minus 2000, drop the power by 1, x to the power of minus 2. Okay, so it's the same process as before. Don't be put off by the fact that this is ds by dx, which you haven't necessarily used before. I still want to find the minimum value within this function. Okay, now I've differentiated. I basically want to find the stationary points. Okay, so I'm going to take this, I'm going to get it equal to 0. Right, it might be worth changing it around first. You have to use this formula, so 2000 x to the power of minus 2. In the same way we change this out, we change it back to 2000 over x squared. But I'm trying to solve this equation basically equal to 0. So for my stationary points, I'm trying to find a minimum value, ds by dx, so the function that I've just got will equal 0. Okay, now you've got an equation, solve this equation. Okay, so do whatever you can to make this simple. Right, first thing I'd be thinking, I don't like fractions. Okay, I want to get rid of the fraction. Okay, 2000 over x squared looks too daunting for me. Get rid of it. Times by x squared, just make sure you times everything else by x squared. 2x times by x squared is going to be 2x cubed. 2000 over x squared leaves me with 2000, and 0 times by x squared just gives me 0. Okay, now I've got something that's a lot more easy to work with. But what I'm trying to do here basically is I'm trying to factorize or solve. If it was x squared, okay, you'd want to factorize it. Okay, I'm going to do that process. I think no, I'm not. Okay, so I can move everything to the other side. If it was x squared, I would need to factorize, but because it's not, I can actually move the 2000 to the other side, and I can just solve it that way. So divide both sides by 2, x cubed equals 1000, in which case x is the cubed root of 1000, and 10 times 10 times 10 gives me 1000, so x must equal 10. Right, so I've only got one value, which is good. Don't be put off by that, and don't try and do anything stupid like thinking the cubed root of 1000 is 10 or minus 10. Minus 10 cubed is minus 10 times minus 10, which is 100, and then times it by another minus 10 is minus 1000. You only get one answer for the cubed root of something, okay? Just 10 in this case. If it was obviously the square root of 100, it could be 10 or minus 10, but there's only one value here, so think about these things. Right, so I'm going to take that value, and I need to just first of all establish that it is a minimum value. Okay, so I need a nature table. There's only one value to work with here, so it's a smaller nature table, nice and straightforward. X ds by dx and the shape. Okay, I'm just proving basically that this is a minimum turning point on the graph, or a minimum value in terms of the function. So I've got 10. I know that's equal to 0 in the derivative, in which case I know the shape is flat. So I'm thinking of a number before 10. And after 10 to determine the shape either side. So I can pick anything less than 10. So I'm going to pick 1 because it's nice and easy to work with, and substitute into my derivative, and I get to minus 1998. Don't worry about the 1998. It's the fact that it's negative. Okay, that's the important bit. In which case that means my derivative is negative, which means my shape is decreasing. Okay, until the point 10, and then afterwards. Okay, I'm going to pick a number that's bigger than 10. You can pick 11. 20 is maybe slightly easier to work with. Bottom line is when I put it into the derivative, I get an answer of 35, and that is positive. Okay, so that means after 10, okay, when the graph hits 10 and then continues, it starts going back up the way, which does in turn prove that this is a minimum, in which case the minimum surface area will occur when x equals 10. Right, lots of work. Think you're finished, but you are not. Read the question. Okay, when you think you're finished, go back and read the question. This says find the dimensions of the tin which minimize the surface area. Okay, if it's the dimensions, then I need my value of x, I need my value of x, and I need my value of h. You will not get full marks unless you answer the question. Yes, it's true, x is 10, but there's a third dimension there. We need to find out what h is. Right, and in the first bit, we actually found a formula for h. H was equal to 500 over x squared. So we take our x, we substitute it in. 10 squared is obviously 100, so it's just going to be 500 divided by 100, which is 5. So the dimensions of the tin are 10 centimeters by 10 centimeters by 5 centimeters. Right. A lot going on in that question, but it's virtually the same as what you've done before. It's just a context. So a couple of things to be careful of. Don't worry too much about the first part of the question. As I say, my next video will be just looking at those formulas and just trying to work them out from the information that's given to you. Okay, because there's a whole variety of different things there. But once you get to the second part of these questions, and generally they are all set up in the same way, it is just a differentiation, get it equal to 0 because you're trying to find stationary points. If there was an interval, you'd have to look at that, but there wasn't an interval for this one. Okay, so it's just following that through, finding out, proving that 10 is actually a minimum, and then finding the other dimensions. So read the question carefully And yeah, you'll see it's just pretty much the same as what we've been doing.